So hello, my name is Carolissen and this is my presentation for my assignment. So I investigated problem solving, more specifically problem solving in computing. So problem solving is the process of identifying an issue, understanding the issue and understanding the nature of the issue. And after you understand the nature of the issue, you then come up with solutions and then implement those solutions to solve the problem. And in computing, problem solving involves understanding the problem, designing an algorithm, coming up with solutions, and then implementing those solutions. In the real world is also very similar. You understand the problem, you gather information about the problem, come up with those solutions, and then implement those solutions to again solve the problem. So like in software development, problem solving is a very crucial factor. It prevents bugs from being in the code. It encourages innovation, it enhances the user experience, and it creates a more efficient application. So whether it's in computing or in the real world, problem solving drives to create innovation and better decision making. So 4 problem solving techniques that you can use is process of elimination, the Socratic method, means end analysis, or divide and conquer. So process of elimination involves eliminating certain factors to better understand the problem and then more easily to come up with a solution, because you don't have to worry about unnecessary factors or information. You just eliminate those and then you come up with a solution. The Socratic method is about talking, asking questions to better understand the problem and to come up with solutions. So yeah, divide and conquer is breaking up the problem into smaller tasks that's more manageable, which enhances efficiency, and it's much better to do smaller tasks than one big task. Then means end analysis is analyzing different factors. So you, like if someone were to travel, they will look at the ticket prices for an airplane, hotel costs, taxis, all of that. So those are different techniques you could use. So in question 2, I had to solve a scenario. So first I broke down the problem logically. So first I said the system receives multiple readings in degrees Fahrenheit. Then I need to convert those readings from Fahrenheit to degrees Celsius using the formulas. The temperature in Celsius is equal to the temperature in Fahrenheit minus 32 degrees times 5 divided by 9. And then I need to implement some sort of problem solving technique so that I can better understand the problem and I can make it more efficient to solve. So the problem solving technique I used was divide and conquer. So I would handle each temperature reading on its own. This divides the problem into smaller independent sub-problems, which is much more easier to manage and to solve. So then I would convert each temperature reading on its own from Fahrenheit to degrees Celsius using the formula. Then I would collect the data I get and display it so that I know, okay, this is my answer, my results. So then I also wrote some pseudocode. You can view that in the document. It's quite long, so I don't want to bore you or anything, but it is in there. So why I used the divide and conquer method is because this requires a lot of conversion and a lot of thinking, and it's a bit complex. So if I did it all at once, it wouldn't be as efficient. So I would rather break it up into smaller groups, handle them individually, and then later I could combine them into a longer list. Then I know this is the reading for this is the reading, this is the reading, this is the reading. It reduces complexity and it's way easier to solve the problem using divide and conquer. So if I were to compare divide and conquer method to the brute force method, the brute force method is where you just convert all the data just at once that would just take very long. It's not as efficient, not good at all. Whereas if you use the divide and conquer, breaking into smaller tasks, way more easier to do and way more efficient. So there is always that doubt of input validation. So sometimes users may type in numbers that is very wrong. So I would combat that is I would have a piece of code to check if the reading or the entered information or data is a numerical value. Then I would also put in a range so users can't type in temperatures below absolute zero, because those are values that you can't get. It's impossible to get those values. And also have a certain temperature that is very extremely hot, so that users can't type in, let's say, the temperature of the sun, because that is impossible to have here on Earth. So that's two of the things I would do to encourage accuracy and, how can I say, validity of my data. So yeah, thank you for listening, and yeah, thank you.